Place for anyone that genuinely gets stuck at the bottom and can't get back up. But if you definitely feel that you cannot get back up 13 flights of stairs, I would encourage you please Parramatta. They're all very talkative, they love, and you're free to wander. We'll hang around if you've got any questions, by all means. Last bit, so our toilets are here guys, so either...
Gee, I'm glad it's been really heavy across here.
See this Protectra side maintenance only. It's better for people walking, people or workers walking. Oh, see this one. It's a massive area. The machines. Look at this shower. See the scaffolding? This is very important in a site like this. Access scaffolding. Workers, it's a very expensive part of this project. So it needs to be certified by a scaffolder, engineer, structural person. They are very steep and they need to be checked and tagged. Scaffoldings to be tagged in an event of rainfall or any. So these to be checked and tagged properly. It's safe to use. Look at this. Say thank you for my friend Manoharan. He's the one actually offered this entrance ticket. Okay, we have to book this sort of tickets in advance. Look at this tunnel. It's a train. So we are going to get into this top of this machine. It's a tunnel boring machine. They call Dorothy. I think it's used in several projects, many other projects. சிவருங்க இது வந்து இப்படி சும்மா இதாக இருக்குது. இதை ட்ரில் பண்ணி எடுக்க போயிடும். another machine, tunnel drill punter machine. This is the one drilling tunnels.
Charles, Charles.
Yeah, I'll get it.
It's a good opportunity. See the track. This is where it's moving.
Okay guys, so I'll give you a bit of a quick rundown just on the machine. So this is TBM Dorothy. We've got two. TBM Betty is in the opposite tunnel behind you. She's about 200 metres to the back of the machine at the minute. So when you look in the tunnels a bit later, you'll be able to see the back of that TBM. This TBM arrived here end of last week. We've pushed it through now to the position it's in. On Monday this machine will be leaving, heading on its way straight through the rock face to my right towards Westmead. So this machine is a open face machine. So what that means is all the rock that's cut away at the front goes straight up a screw, straight onto a conveyor, and similar to the one that's behind us, and all the way down the tunnel back to Rose Hill, where it's disposed of into a big shed, and we send all that for recycling. Now the open face machine means you can actually almost see through the machine to the cutter face. So there's no like separate shield at the front of this machine like there would be with an earth pressure balance machine. Okay, so open face is great production, really fast machines. They'll do 200 metres a week on average. That's pretty much what Tom and his team are doing at the moment. Faster than the EPB machines. But the sacrifice is they're not so clever if the ground gets silty and very soft, and they don't like water. Okay, so we have to be very sure about the geology we're mining through before we actually choose this type of machine. Now in terms of operation, you see this machine's kind of split into two cans, a front can and a second can, front shield and second shield. Okay, you can just see that gap in there. And then on the second can behind, when you walk alongside, you'll see what looks like a bit of a door cut into it. That's actually the gripper shields. So that gripper actually comes out from the face, and it does the same on the other side, and that grips against the rock as the machine is moving forward. So the back shield is actually held in place, gripped against the rock. Shield then, the tunnel team are free to build the concrete tunnel rings, which is a make of 6 precast segments, about 3 tonne each. While pumped by pushing against the second shield. So we can be mining with this machine and pushing forward, while in the second shield we're actually building the concrete ring. We then have to do a little stop to snake the second shield forward, but ultimately the benefit of this type of machine is we can mine and build rings at the same time, and that is the big advantage of this type of machine. Okay. In terms of production, like I say, around the 200 metres a week mark. All spoil is out through conveyor, all material comes in through the tunnel. So you'll see on the other side again where the machine's operational, you've got that whole array of service banks on the other side there. At the very top you've got the electric cables which power the machine. Underneath you've got grout lines, water lines, compressed air lines, and the return water lines. So water lines going in, pump lines going back out to the water treatment plants. All that services this machine. Segments come in on something called an MSV, and don't ask me what it stands for, Tom might know better. There we go, right, I can never remember. They come through carrying 2 rings at a time, so rings are 1.5, I think? 1.5? 1.7 metre long the rings. So 2 rings at a time, 6 segments or 12 segments on an MSV. Also brings with it all the service pipes that you see on the wall to extend the services as it moves along. Okay. How long to build it? Do you want to say how long to build a ring, Tom?
So the machine will cut at around 100 mil per minute, and so one cut will take around 17 minutes.
Okay. And in that time, what, they'll build a ring? 15 minutes, 20 minutes?
Yeah, so on a good shift we're anywhere from 15.
Okay. Which adds up, so we mine basically Monday to Friday, 24 hours, and then Saturday, Sunday is maintenance on the machine. So that's where the guys go in and do all the work. Now you'll see on the carriages behind, this machine is 170 metres long, roughly. So you're only seeing the very front of it. There's a lot more of it in the tunnel back there. And when you look at the carriages at the back there, you'll see the centre is fairly hollow. That's because the MSVs drive right up through the middle, so you can imagine how slender these little machines are that bring the rings in. And the cabs are even smaller, so if you're a big individual, you can have a bit of fun getting in and out of the cab. They're very tiny. They bring the machines up. The ring handler behind picks the segments up off the MSV and puts them into position on the machine, ready for the ring erector to actually put them into position. Now they're picked up off the machine through suction. We don't bolt them to the machine and pick them up and put them in place. It literally vacuums it. So it puts a seal down on it, creates negative pressure and lifts it up, spins it around and puts it into the face. The guys put the temporary bolts in to hold it in place and release the vacuum. And then it stays there. Once you've got a complete ring, the machine can then nudge, the back cam can nudge forward to catch up with the first cam. Okay, as we mine. As it slides forward, behind that concrete ring to fill the gap that exists from the back of the concrete to the actual cut face of the rock. And that takes your void up. Once you get a certain number of rings in advance of the one you've built, you can take the bolts out. So I think it's about 8 to 10 rings, something like that. And you can start taking the bolts out of the rings that are built. They're no longer needed. They're purely there to hold them in place till we've grouted. Yep. Between each ring and segment, there is a little rubber gasket which provides all the water tightness. So that rubber gasket is, as the machine pushes off, the back cam pushes off the ring, it pushes the gaskets together and makes sure that they're solidly locked in. And that means we get water tightness in the tunnel, hopefully, most of the time. Occasionally we have a little bit of fun fixing that, but most of the time it works.
Machine loudness, decibel, do you know?
Yeah, very quiet. So these machines, people probably have a feeling like, you know, like a rotary drill at home where they spin really, really fast. This wheel will turn like once a minute. Yeah, it does not turn quickly. It's the pressure that's applied to it and that slow grinding motion that takes the ground away at the rates Tom was talking about. Yeah. Another little interesting fact, I suppose, the rock face that's actually cut is not exactly the same size as the steel can that you're seeing there. The main purpose of that steel can is to protect the people inside and stop the rock collapsing into the machine. It's not actually to hold the ground back. We actually cut 15-20 mil bigger than that diameter of the steel ring. And the reason you have to do that is if you imagine if you try to push something exactly the same shape through a hole, eventually it just jams, right? That's exactly what would happen with this machine. So we overcut a little bit and the machine slides into the ground with a tiny little annulus around it so that it doesn't get stuck. It also means when we're turning corners, which you'll see when you look down the tunnel, it's very deceptive when you build one ring, but over a series of rings you see it change direction. If we try to tilt that machine very quickly and the hole was exactly the same size, it immediately becomes ring bound, right? And you're stuck in the ground. And when you get it stuck, you're done. Yeah, you're digging it back out. So you don't want to go there. Machines are great, they just don't reverse. Right? They're good at going forward, but also clever going backwards. So interesting little fact most people don't know, we do overcut a little bit. And the way we do that is usually gauge cutters on this machine, which are currently not on. So there's different teeth as you can see on this machine, all designed to do different things. 20 mil I was talking about. Okay. Other than that, guys, really the interesting stuff at the back. Happy for you to ask questions. That's tunneling 101. We can have a look up and down the tunnels. If you wander over to the red area, have a look up and down, ask us questions. The only other one thing I will address, which has been a common question this morning, is why is this great big steel frame attached to this tunnel behind us? So if I move over here for a minute. So the steel can goes against the ground and the carousels behind, you'll see the wheels on them are like sort of this. They normally run down the tunnel profile on the concrete segments. Now because we're going through a rectangular shaped box, we've got to mimic that same action, and we do that through these rails. So the steel can of the machine slides through on the rails at the bottom, the lower rails. And then as it slides through, we put these extra pieces on behind that you can see attached there, that the carriages actually run along on their wheels on, to move it from that side of the box through to here. Now then, the steel frame. You'll also note there's one steel ring at the portal to that tunnel instead of the concrete. So when the machine on Monday morning, this machine will push against the face and it will slowly start to grind in. But it can only push at that point against these steel rails. So it can't push with a full force that we can normally use, a very small force. So we do that very, very slowly with the force we can use until that whole can is buried in the ground. What we do then is we build that steel ring behind inside the actual can of that machine, and then we offer up this frame. So we'll take this frame off here, we'll move it to that side and offer it up to the back of that steel ring. And this then is anchored into the ground. You see these big blocks? That's not just sitting at the ground, they're anchored into the rock about 7 or 8 metres with a lot of big rock bolts. Okay, that enables us then to push with the machine with much more force, so we can get back up to our more normal production rates. Once we're a certain length in, this becomes redundant. We don't need it. The physical friction of the tunnel with all the segments and the grout behind them provides enough resistance that we can just push against the rings. But for the first section of tunnel we do as we go in, we need this thrust frame to push the machine off. We do indeed, yeah. So when this machine gets buried next week, this will be dismantled and moved over to this side. Yeah. And then as you can see here, we've taken all of the beams out now, the traverse beams. We'll be doing the same over here in a couple of weeks' time when this machine has pushed its way through.
Yeah, so where's that TBM right now? Like, has it reached Westmead?
It's about 100, I'm going to guess at about 200 metres to the back of the machine down the tunnel at the minute.
Okay.
So when you stand there in a moment where those red barriers are, you'll just be able to see the back of TBM Betty.
Oh, nice.
Yeah. It's a long way up there.
What's the cycle of like putting a segment in? So how long would it take to do, say, 2 segments if you're doing full production? Would you do?
Building one ring. So Tom was basically saying do 1.7 metre mine about 20 minutes.
Yep.
Ring build 20-25 minutes.
Oh, okay. So every 40 minutes you do a segment.
Yeah, or quicker, 25 minutes. Because like I said at the beginning, you can do both activities at the same time.
Yeah.
Because that front can push forward and mine independently of the ring build in the second shield. So you have a little bit of gap there where you need to snake the second machine forward off the ring you've built to catch it back up with the front one and bring the gap back to what it is now.
Yeah.
So every 30-35 minutes a ring, you probably won't be far off.
Okay.
And then you'll get downtime. That's why we only do 200 metres a week. You can do more than 200, but of course with any complex piece of technology, you get breakdowns, maintenance, hoses snap. So you need to do that constant repair to machines as you go, which ends up bringing your average down. You can't always smash it at the maximum possible output every day as much as we'd like to. A week we could do about, we say we average 200 metres, which means we do about 40 metres a day, 20 metres a shift. 20 metres, linear metres. So that shield there is probably about 15. So if you say add 4 or 5 metres to that shield, that's about what we're doing in our shift. Yeah. So to do 1.2 kilometres would take 6 to 7 weeks.
Oh, okay.
Yeah. Yeah. And that's considered quick. Yeah, that's considered quick.
And in terms of the geology, I heard like as you go towards Parramatta out this way, you're getting more clay. Right?
So the machine, so because this is an open face machine,
Yep.
it needs to be in sandstone.
Yeah. Okay.
It can't deal with the clays and the soft material above. So the geology at Parramatta in here, and those that were here about a year and odd ago will know, the top 15 metres here is either a clay on this side of the box, very stiff clay,
Yep.
but on this side of the box it gets a lot more silty, so a lot more sand in it. You start to hit the Parramatta sands.
Yep.
Under that clay you get about 1 to 1.5 metres of shale, which is like a really soft, slaty type material that breaks into layers. Very, very thin, only about 1.5 metres.
Okay.
Over thousands of years that'll turn into clay.
Okay.
And then immediately under that you get the sandstone, which is this stuff here. And it goes immediately to class 2 sandstone, so you don't get this gradual transition from, say, a soft fractured rock where it's all broken and whatnot. It just goes immediately to a class 2 sandstone, which, as you can see from that, there's very few joints, very little crumbling, and that's why we're able to leave that face like that without the shotcrete on it, because it's so monolithic. We don't need to add that temporary work support to it.
So what you do if you find any unexpected pile foundations from
God help us. We hope we got the geological surveys right. So we know where the buildings are. If there's any doubt, we do more geotech investigation before we proceed. We would never mine under a building that's got piles in it through a pile. There's two reasons. One, it's not good for the building. And two, these machines like everything except hardwood and steel. Right? They do not like hardwood and steel. It will pull the teeth off the machine, it will break the machines, it chews up the belts, it chews up the screw. It's a disaster. Right? So you do not want to go through steel and hardwood.
Just curious, like, is there any reason why you guys like start tunneling like here, but then the station box extends like
Yes.
a fair bit?
Yeah. So basically, our aim is always to try to dig the box before the machines get here. We didn't quite manage it in this case. We knew that was a possibility from day one. So we've managed to take it as far as we can before the machine's here. And the simple truth of it is economics. It's far more expensive to stop the machines than to do this bit of excavation afterwards. So stopping the machines for a period of time is very expensive. Every day they're stopped costs a lot of money compared to the excavation of the station box rock, which is comparatively cheap in comparison.
Right, so eventually like all this rock over here will get excavated.
Correct,
out for the box.
that's right.
Yeah.
So one of the things, it's a good question, because one of the things we do is, like you'll see, we've built permanent tunnel rings in there. When we're manufacturing these segments out at Eastern Creek, we're manufacturing 80, 90 a day, I think. We get a certain percentage that are defects. We target under 2%. I think our percentage is really, really low. But those defective rings are kept and they're used for things like this. So where there's like a bit of chipping off the corner of one or something, or there's a slight crack in one, we'll keep them because they're still structurally fine. And we'll use them in places like this where we know we're going to be breaking them out later, so they're not wasted. You know. And then all the spoil from here goes down the conveyor. Like I said, everything's reused. So even the excavation of the station box material, nearly almost everything is reused, unless it's really, really, really badly contaminated with something like, you know, friable asbestos, chromium, and even the friable asbestos in this job we've reused by the new stable inside in Sofa at Clyde, where we're going to have all the new facilities to look after the trains.
And how many team members?
So on the physical machine, it's a crew of about 13 people. You'll have a couple of guys doing the ring builds, you'll have some guys doing grouting, you'll have some guys doing maintenance, injecting oils and lubricants, and you'll have guys at the back extending services. Then you've got the operators for the MSVs. We've got the guys at the Rose Hill dropping and loading all the MSVs from segments. You've got the guys in the spoil shed, up at the spoil shed at Rose Hill then, disposing of all that excavated material. And you've got the crews out at Eastern Creek manufacturing segments and loading the vehicles to bring the segments to Rose Hill.
Does someone actually like steer this TBM? Make sure.
Do you want to answer this one, or do you want me to do it?
Yeah, they do. They steer the TBM. They're operating off the ground pressures. The machine is operating forward. They're sensing the pressures in the ground, and they're steering the machine on top of the ground. Right. So they're around. Right. But yeah, they are steering it. There's a little cabin there. Someone sits. They're driving that machine forward all the time, coordinating the segments, coordinating the rings, pushing forward. One thing that the motor sort of spearheaded is there's actually an autonomous machine, so it can drive itself. It's got software in there that actually senses ground pressures, so it actually almost makes the operator role redundant. So
that behind, when you look at the wheels, they're on a bit of an angle, and they're made to match the profile of the tunnel. So you can see how the top one kind of runs straight onto that steel segment over there. So then wheels then just run down the tunnel on the sidewall. Go on. That's the bucket for an excavator. A little excavator. Yeah, so we take them off and we can change them to use different types of bucket depending on what we're digging in.
So we use this machine to dig the tunnel over here?
No, so there's two machines. There's Betty and Dorothy. This is Dorothy. Betty's down that tunnel. Yeah, you'll be able to see the back in a minute when we move round there. In fact, we'll move there in a second because we've been here a little while now. But you'll see the back of the machine. Each machine does about 9 kilometres. Yeah, and you can reuse them. We're not actually going to reuse these ones. We're going to salvage the parts that we need to give back to the manufacturer. But generally, these machines will get cut up.
who own this machine? Sorry, who own this machine and how much will be the higher charge?
The costs I can't tell you, but we as Gamuda Langaroke own the machine. Yeah, and we buy them from a company called Herring Connects. There's not many manufacturers of tunnel boring machines. So the two biggest by far are probably Herring Connect, who designs this one, and Robbins. And if you go to the US, you'll find there's a lot of Robbins machines. Yeah.
So,
Oh, sorry.
Yeah.
So when are you likely to tunnel to Westmead?
Westmead, it should be, all things being well and the machine doesn't break down, 5 or 6 weeks.
5 or 6 weeks?
Yeah.
Wow.
Yeah, with that machine, with this one here. This one will be a bit longer because we haven't relaunched it yet. So this will be a bit longer. And driving through this bit of the box here, you see how we've obviously excavated. So there's only about 1.5 metres of rock over the top of the machine while it goes through the rest of the station box. So while we do that, we don't push at full force because we don't want to heave the ground on top and burst the rock out at the top. So we push forward a little bit more gently until we get to the D wall. The D wall, sorry, is this big diaphragm, this big concrete wall going all the way around the perimeter. When we get to that, which is about 120 metres that way, we'll push through the diaphragm wall and then it'll go back to full speed because then they've got 30 metres of ground over their head.
How many machines are in Sydney at the moment?
Oh, I honestly couldn't tell you the answer. There'll be a couple on Central Tunnel package, there's a couple on Eastern Tunnelling package, and we've got 2. There'll be more for the harbour crossing job that's going on at the moment. I don't know whether they're using 1 or 2 machines. And I don't know if there's any more beyond that are being used because I think the M6 is all road header, so it's not using tunnel boring machines. Come on.
Can we move?
Can we move? Yes, we can move. Very good prompt. We'll go around to the red barriers and then you can see up and down the tunnels. And we'll come over there so you can ask us any more questions you've got. So they won't build them trains to be that long when they start. They usually do like an 8-car train or something is what they used to do for Sydney trains.
Yeah.
Might be 150, 160, 100%.
Okay.
Yeah. So and you typically, yeah, 100%. Yeah. Typically they're all in the soft. So if you're going to find gas or electric or anything like that, I'd say once you're below 3 metres, it's highly unlikely. The only ones you usually find any deeper than that is usually the sewer. Yeah, and stormwater. They're the 2 that are usually the deepest. Where you could be up to 5, 6, 7 metres, depending on the grade of the ground that you're in at the top. Yeah, no, you can't hit anything, I can assure you. Yeah. Oh, the throat's giving up on me. The throat's giving up on me. Yep.
Nobody asked any questions last time.
Really?
I was shocked. Luckily today's made up for it.
Yeah. No, it's good. I like the interaction. Yeah, it's a lot of work. It's people always, you see all the trees are hoarding at the top and everyone wonders what we're doing, you know, and so it's great to bring people down and actually show them what we've been doing. We haven't been sitting there.
It's amazing. It's absolutely amazing work that's been done, and I think a lot of people when they come down here, they really appreciate how much time and how much effort it takes to build. You know,
Yep.
Westmead.
Yep. Yeah, we're nearly there. Nearly there. We'll be along now. You'll be seeing the ministers.
I'll keep an eye on about 5 or 6 weeks.
Yeah. Is the next? How are we doing? Oh, 150.
She's just a bit down. I think she got bored because she lost passages.
There are indeed, yeah. Every, if I can remember, we go.
Oh, you
yeah, so as we pass them, so like as we go that way, and we do, once the other TBM passes, we'll start mining through. So we put a beam over the top of the segments, we take out some concrete segments, and we start mining through to the other tunnel manually with robotic excavators.
Oh, okay.
And then once that's done, we shotcrete it, we bolt it, and then we put the pulls together then. So that has to be done for emergency. Yeah.
And then that would be quite slower because you've got the robotic ones and it won't be as...
Yeah, how long it takes them to dig. Tom might be able to answer that question better than me.
Yeah.
But yeah, it's a much slower operation. But they are much smaller than that tunnel. They're not that size. They're literally designed for people. But normally the conveyor belt will be running, taking material out. The ventilation will be on, providing fresh air to the front of the tunnel.
So when this is complete, we're now standing in the...
Put something, clad it with something, I don't know. But you'll probably get your advertising boards and all your services running down the side and whatnot. Yeah, and these steel frames will come out. These will be replaced with concrete slabs, which will have all your escalator openings and your lift shafts in. Most time when the public see the stations, you only see about 30 or 40% of what was actually built. 60% of it is actually behind the scenes, like background rooms. So all the plant and maintenance and operational rooms, control rooms, service rooms, firefighting rooms, all the stuff that you never see is hidden away. So these holes, people always go, why is it so big? It's because there's a lot of stuff goes in here that you will never see. 30 metres there box.
but underground there's a cavern to extend it to be as long as this one for the platforms, which is quite a size. It'd be nice to take people down there really, but it's difficult to take people underground at Westmead because of the respiratory protection we have to wear.
Yeah.
Then beyond that there's a crossover cavern because Westmead's the end of the line, so when the trains go up one,
Metro tunnel is underneath, say, road level, like from here, because I think you notice it dips down.
I'm guessing a little bit, if I'm honest with this answer, but I would suggest about 45 metres.
45 metres.
I would suggest.
I think like Tops is scored.
Westmead's about 38, 39. This is 28.
Yeah.
I think Clyde's a little deeper.
Okay.
Yeah, I'd have to be. I'm not 100% about that if I'm honest though.
Yeah, okay,
Yeah,
that's all right.
I think I'm right.
So actually, this is high here.
Yes, this all the tunnels here dip down a little bit again to a sump, and then they're going to climb up to Westmead.
It's pretty flat here, pretty much along. You're going basically mimicking the Parramatta River.
Yeah.
You know, a little bit like the Northwest Project, you have that like little, you know, you rise up a little bit to, you know, when you get to the platform, and you dip down a little bit when you get
They've done that a little bit here to keep, because obviously you want to keep as shallow as you can because building the station boxes is expensive.
Yeah.
So you can, if you tunnel 10 metres lower, it doesn't really matter. But digging the big hole down for the station box 10 metre lower and then having that increased depth of escalators and lifts and stuff costs a lot more money. Yeah, that's right, 100%. You could tunnel as deep as you want, to be honest, but building the stations then will be horrifically expensive. Yeah.
Where the Sydney Harbour Bridge is, it's going deeper under the
Yeah, I don't know the geology of that job exactly, if I'm honest, but 100% they'll be staying down at a depth where they're happy that they're not going to get in water coming into their tunnel. But I suspect I suspect they'll be using an earth pressure balance machine, which has a pressurised front of the machine to keep the water out. Yeah.
That's going to be in the Pyrmont box next weekend.
Yeah, that's nice. Are you heading down there?
Yeah, definitely.
Yep. Yep.
Have they got any community days?
Maybe.
Oh, really? I got this one's only yesterday anyway, so yeah. I got two left. It was sold out, and then I just went, I got one, so I was going to go to the Discord channel. At where at Pyrmont? Pyrmont says, oh, that'd be interesting because that's pretty big.
You know, you've got two kind of things. You did an amazing job. It's like we covered everything. It's great. You know, even things like the economics of doing that later. But what would be great is talk about the nozzles. So I've never quite understood the purpose of nozzles. And then the different types of cutting heads on the machine. So I thought maybe we could do one from over there and one from maybe around here for the nozzle.
I'm not in between the stations. For a maintenance purpose, do you have any connections between the tunnels?
Yes, there is. So there's cross passages about every 250 metres. So if there's like a fire in one of the tunnels and you had to stop the train and get people out, you could get out through one of the cross passages into the adjacent tunnel. And that's what I've done. That always happens on every line. It's usually just the spacing of the cross passages is a bit different depending on who owns the infrastructure. Yeah. And it's the same in like North Connects or West Connects. If you go to those tunnels there for the roads, they'll have cross passage connections as well. Every now and again, you'll see like an emergency door up the tunnel, and that's to go into another tunnel, which gets you out safely if there's a fire in there. Yeah.
And for the oxygen ventilation also they have that.
So they rely on the station boxes here because they're close enough together, so you don't need individual ventilation shafts. But the boxes will feed ventilation into the tunnels, which is actually the purpose of that nozzle. So the top plenum of that nozzle runs ventilation into the tunnel and forces air into it.
And the power cable will be on the top, isn't it?
Power cables will all be on the side like this. They'll run down. So when the line wide come in and they do the track build and they run all the power cables down, they'll all be on a series of brackets and gantries. On the side of the wall of the tunnel.
But
the overhead power line will be over the top. Yes, 100%. Yes. Yeah.
Treated nozzles?
Yep, sure.
Yep, we are going to see this tunnel boring machine today. They call Dorothy. It's in Parramatta station, closer to Parramatta station. This will be the metro station as well.
Went to Intersect for that. Yeah.
Before the TBM gets here, because to enlarge the hole above and take it up another 6 metres above the tunnel crown is a significantly more difficult job than doing it before the machine gets here. That's exactly why they're excavated before the TBMs arrive.
And I guess things like tunnel ventilation, station ventilation, might be the kind of things that might go.
Yeah, temporary tunnel ventilation for TBMs aren't really affected. They get fed through with the tunnel boring machine. Until the tunnel machine physically arrives here at Parramatta and is pushed into the box, the air is actually fed from Rose Hill. Once it's actually at Parramatta, it's fed from the Parramatta box back into the machine as it heads west. So at the moment now, you'll see there's no ventilation in that tunnel behind you in terms of bagging, but it's now got natural airflow from Parramatta to Clyde, and it's forced through with axial fans in the tunnel crown.
So the nozzles, so for a station to say on the city extension, those nozzles are probably going to have like ventilation or something.
Yeah, they'll have dampeners and louvers in the slabs that get put in over the top of the tunnel profile, which will allow air to be pushed into the tunnel or air to be extracted from the tunnel into the service rooms within the station box.
And all the spoilers go all the way back to Rose Hill, is that right?
That's correct. All the spoil goes via conveyor back to Rose Hill belt, and all the spoil will be, I'd say, up to a maximum of 50 mil down to almost dust that goes back. No dramas?
I've been trying to work out what accent the whole Northern England?
Yes, Lancashire. Yes, yeah, Blackburn. Yeah.
Yeah, if we have a go at the
Yeah, sure, we'll do that one quickly. Yeah, yeah.
Okay, thanks very much. Thanks for watching. It was a really good experience. I was waiting for this day. I'd like to thank you, Velu Manohar. He was he informed me.
Okay.
This bottom one, huh? This one.
Yeah. Right here.
Okay. Thank you.
Go in front of Dorothy.
Yeah. Thank you very much.
This one needs it less because it's got the
Thank you very much. This Dorothy machine, really appreciated. Good opportunity. If you want to see this one, please watch the site, event site. They have the tickets and everything. It's actually free of charge. Okay, thanks very much. Really appreciate it. Thank you.
You're welcome.
Thank you.
I didn't take a photo. I
That's
just
okay.
did the video. Yeah?
Yep. That's good. That's enough.
so that as the wheel rotates, each individual bit of the wall is actually caught by a different tool. The only exception then to that is these tools nipping off the end here at the minute. So there's more discs that go on the end here, and these are called gauge cutters. And what they do, they move in and out, and they allow us to excavate a profile of the TBM that's slightly bigger than the steel can.
He's explaining that you already watched that one.
The steel can needs to pass through the ground without being too snug of a fit. So it needs to slide through with about a 15 to 20 mil overcut. Otherwise, if it was to go through at exactly the same profile as the TBM steel can, it would get stuck instantly, and then we'd be digging the machine out to the ground. We have to take the gauge cutters off when we push through the station box, because otherwise every time we turn the wheel for maintenance they would catch against the rails that we've got on the ground, which is why they're removed at the moment. And next week, before we start excavating again through the station box, we'll be putting them back on again.
Thank you. Thanks very much. We'll go back outside and see where the exact location of this station. And it's not far from a railway station. It's going to be a metro station, like every other metro stations, you know. Say Chatswood, for example, Chatswood station, similar thing, right? The other one, Epping station. So we already had the railway station. Now they are putting a metro station here. Wow, it's good. See, very tired. Next group is ready. ஒரு 3 o'clock மட்டும் போய்கொண்டிருக்கு. அடுத்த குரூப் ரெடி ஆயிருக்கு. See, helmets. Thank you. See, the other group is here. They are going to get in. One group is out. It's a good experience. I'm going to have a coffee now. It's a coffee time.
No. I can't take everything.
They have found few artifacts, archaeological findings. You can see here. So this is about archaeological findings here. So European and as you all know, Parramatta is very first settlers area. So you can find a lot of archaeological buildings and artifacts, the findings. So we can see this one. Heritage and archaeological investigations is very important part of any civil project. So as you can see, this is one of the oldest area in Australia. When they migrate, they use Sydney Harbour, Sydney area as it was the harbour area, but this is where they lived initially. So we'll ask few questions.
For example, just these two times we've got about 10 like this.
So these findings, how many years old you are?
This deposit is from a well and it's from the 1840s.
1840.
Yeah.
It's from a well.
A well.
How comes it's gone inside the well?
When they backfill it, possibly a local businessman is throwing his unsold.
So they reburied in a well. So there should be a record for that one, correct? For
maybe, I'm not sure about that.
So this
could be people dumping their rubbish illegally.
Yeah. So is there any Aboriginal findings as well?
There is, yeah. We do Aboriginal testing here. We don't have any out today, but we have, this is the date from up to 7,000 years old.
7,000 years.
Sort of hand axes,
artifacts, tools.
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 Flakes from when they're making the tools.
So these things maybe that time imported, or when the Europeans first migration, say.
So these are all English made, and they are brought over, and also as a trade, so they're continuously shipping these over, and then they're sold in stores in
So is there any way you can find the age of these ones?
Yeah, the age. So sometimes they have a maker's mark on the back, which will have
Right, company
maker.
background.
Yeah,
Okay.
exactly.
Product number sort of thing. They keep
Yeah,
track.
and you can, not all of them are marked.
Yeah.
But a lot of the time you can look up the maker and see what date range we're looking at.
They would have turned some of the ceramics at once being intentionally worn down.
Otherwise, they're dated by the design and the pattern.
Right.
For example, the coloured transfer print, like the red, the green, and the brown, was not used until the 1830s. So we know that if we get coloured transfer print rather than blue, we're looking at a 1830s last date.
Which ones are the pre-1830s? Sorry, the
Pre-1830s is blue transfer print.
Okay.
Post 1830s is the coloured. So
Oh, really? They were able to do different colour ones, so they worked it out.
It's not a surprise.
Like how long is it all like water earth?
Yeah, 200 years ago.
How long do you think that is?
It's going to have energy.
These are all kind of, a lot of these are like transfer.
Okay, cool. Wow. And we're just basically inside where they used to
hand painted.
old houses.
Hand painted Chinese ceramics. You see the maker's mark. So these ones are as opposed to these ones which
a fairly
Yeah, fair enough. Okay, gotcha.
Sometimes you get like
முதல் ஆஸ்திரேலியா பிரேக்கில் அவர்கள் கொண்டு வந்த அந்த பிளேட்ஸ் அதுகள் இருக்குது. அதற்கு பிறகு ட்ரேடிங் செய்திருக்கணும்.
materials the coins as well. I remember hearing Australian coins. There was an Australian coin that was just rising prices of things one time. The currency itself was worth less.
This was a mid-19th century invention.
So people were melting them down and then selling them. So it's always hilarious to think about the values worth something versus how much it's actually worth.
They're all pretty pipes. So smoking pipes.
Smoking pipe.
They started off in the 90s, early 1800s. They could be about that long, but they broke easily, so they start getting shorter. And, you can see the pictures of all the guys. To get like little gaps in their
That's amazing.
So we get a lot of these because obviously people smoked a lot, and they drank a lot, and they ate a lot.
Enough people do it,
And stuff up there. Did you look up there?
Yeah, we're looking at the points. Sort of, what normally happens. A little bit like where we don't have one set or two set coins anymore. There's a point with inflation where they just become completely worthless.
And I mean at some point too we'll probably go completely beyond
Coins, the one they use. See the clips.
notes, and we're already kind of there, but then we might go further into sort of just plastic and like sort of e-currency.
And the Vuna bonnet.
They've been gone for like 35 years, and most people wouldn't even think of 5 cents existing. A lot of places don't even accept them.
No, well you get
Railway token, Sydney railway token.
Very true.
So there's a lot of that, happens.
So archaeological findings. See the bottle.
Population.
See the bricks.
With the bricks, they're just like generals.
Yes.
Any Arab sort of bricks, like early 1800s or.
Yeah, this one is about 1800, 1810. It's got that arrow in it, like the convict arrow.
Yeah.
You can see it's kind of quite poor. These are handmade. It's quite poorly made. This one's a little bit younger, so this is 1850s. You can see it's just it's a bit better made. And it's got that heart shape in it, which is
okay, it's cool. Yeah, because they obviously need to get paid by the by the and that was their brick sort of thing.
So you get the marks in to show the different yards, whose brick it was or which brickmaker it was.
I think the Rose and Crown around down the corner there, that's sort of same brick, and it's one of the oldest existing pubs that have never had a change of license or thing that goes back to so the Rose and Crown on the other side of the river on Victoria Road, not far from where the light rail goes through there on Church Street and Victoria Road. Yeah, across from the Woolies, that one part there. Yeah, there's a plaque.
I can visualise it.
It's got a distinctive red brick like that. That's why I went. It's the same brick.
Same brick. Yeah, they're pretty good at it.
Yeah.
These bones, what animal?
They're cows. Yeah. So and these are like probably sheep or goats, you know, because they still got the horns. So we get a lot of animal bone on site because people are, you know, they have they're butchering for the meat, for food. Like, you know, if we buy meat now, we often just buy it in the packets in the supermarket, whereas, you know, back then people had to do their own work.
So how do you find how many years old these bones are? Carbon.
Yeah, you can do that, but we often find because this is not that this is from the last 250 years from the convict era. Yeah, so we kind of already know roughly how old they are, and often you find them with pottery or with other things which we normally age. But you can, if you got something along older, you can get carbon dating on the bones as well. Yeah, if you needed to, like something that's really, really old.
Yeah.
Yeah, so you get a lot of these ones where you can see where they've been, like butcher mark.
Yeah, the railway tokens are
little butcher marks.
Yeah, cut.
And then this is, you know, from one animal which they've broken it down. But, yeah. And this is the oyster. The mud oysters are very large oysters. We used to, they kind of died out. They're local. They kind of died out. But you know, in the early 1800s, so they ate them all. So basically,
I think I know the one you're talking about.
No, maybe. I think I don't know the full size, but because they got the horns, I think they're probably adults. Yes. But I think actually that should be this way around.
It looks like lingo.
Yeah. So this the
kangaroo.
Their heads would have come out here.
Oh,
yeah, so that's the spine.
Oh, that's why.
Yeah.
It's why it looked like a baby, but you're right.
Yeah.
Yes, this would be
the head would have come out here. Yeah. So it's not like no,
yes.
It's not that. Yeah. So they would have come out here.
Like that way.
Yeah.
They do the kangaroo or?
No, it's like a sheep or a goat. Yeah.
There's a famous.
So yeah, so it would have been out to here. You can see what the nose was.
So what bottles are these one and where are they made of?
Yes, so we've got a range of bottles. So these would have been your beer and wine. And then we've got these are for ink, like for writing, ink wells.
Oh.
These are little ink wells.
Ink, yeah.
Yeah. Actually, I don't know what does that say. Do you have your glasses? I don't have my glasses, so I can't read that.
Yeah.
I don't know what that says.
Dressings.
Could be a perfume or I can't read it. I don't have my glasses. And then we have these, which are sodas. Which is a soda, and this is cordial. And it's a ginger beer.
Ginger beer.
Non-alcohol. It wouldn't be an alcohol.
So this one imported from England that time or local?
No, this is local. So this one is Summons and Graham. You can read the Summons and Graham, and they're from Parramatta.
Oh.
So they had a factory in Dixon Street, which is over there somewhere. But they were Summons and Graham were about 1880s. They started making cordials, cordial and aerated like soda water,
right?
Like a soft drink.
Yeah.
Is that what it's called? Soft drink.
Yeah, mixed with water and.
Yeah,
they make it like
so they were operating up to the 1950s. So that's local Parramatta.
Yeah. Or you have to, go by horse.
Thank you. Very interesting. Yeah. Oh yeah, it's very interesting. This archaeological stuff, right? Convicts area. Mundi vandu convicts. They convict Parramatta. Yes. தண்டனை கொடுத்தாக்கல கொண்டு வந்து இருதின இடங்கள் பழைய கன்விக்ஸ் ஏரியா பார்த்தீங்களா கன்விக்ஸ் ஹட்ஸ் அவையில் இருத்தின வீடுகள் இப்பயும் இருக்குது சம் ஆஃப் த கன்விக்ஸ் ஹட் யூ கேன் சி ஐ டென்ட் நோ தீஸ் ஆர் த கன்விக்ஸ் ஹட் வாவ் Okay, thank you very much. நாங்கள் போகலாம். Thanks for watching. coins இருக்குது சிட்னி ரயில்வேக்கு கொடுத்த coins எல்லாம் இருக்குது. இதுக்குலேருந்து எடுத்த இந்த பர்டிகுலர் லொக்கேஷனில் எடுத்தது தான் இதில் காட்சிக்கு வச்சுக்கணும். சரி, ஓகே, தேங்க்ஸ் வெரி மச். தேங்க்ஸ் ஃபார் வாட்சிங். See you again in some other areas. More than 100,000 artifacts have been found during archaeological excavations on site to date. இதுவரைக்கும் 1,00,000க்கு மேற்பட்ட ஃபைண்டிங்ஸ் நாங்கள் இப்போ பார்த்த மாதிரி எடுத்துக்கணும். Each TBM is approximately 170 meters long. That's longer than the length of the two A380 airplane and சொல்லினோம். Right? Each TBM weighs almost 1,200 tons, equivalent to the combined weight of 20 elephants. Did you know TBMs Betty and Dorothy have excavated 1.25 million tons of Sydney sandstone since they started tunneling in late 2023? That's enough to fill 204 Olympic-sized swimming pools. In March 2025, TBM Dorothy cut through 279 meters of sandstone in 1 week. Typically, Dorothy advances about 200 meters per week. It's very quick. The steel in the station box weighed 2,500 tons. They're about a quarter of the Eiffel Tower's weight. Wow. Okay, Robagale, thanks very much. Thanks for watching. I will finish. Okay, they are giving a ice cream here. I'm going to have some ice cream as well. Okay. Sydney Mailway Retro Petty Sila idu ellaam irukku. Okay, thank you very much. Thanks for watching.